Our talk today is joint work with Svetlozara Leseva, presenting the consistency evaluation procedures to enhancing the concept representation of verbs in WordNet. So what I'll cover is some introductory words, and then I'll outline our work on mapping WordNet to FrameNet. Then I'll go to consistency validation procedures, some discussion on evaluation, and then we'll conclude with some remarks. Our long-term objective is to provide conceptual description of verbs in WordNet by mapping WordNet to FrameNet, and also some additional resources like VerbNet, which we at the moment we don't fully use, but we intend to include more information from there. We also would like to ensure that the description is consistent and unified, because what we get existing mappings and other resources from different sources, and we would like to compile them into a unified and consistent system for describing conceptual information of verbs. And also what we would like to confirm that is the validity of conceptual description across languages, so that when we use information provided for one language, we need to make sure that it is valid for Bulgarian in particular as well. So our resources, the two resources that we use in this study are WordNet, which is, as we know, a large lexical database that represents conceptual and lexical knowledge in the form of a network of synsets, which are interconnected through a number of conceptual, semantic, and lexical relations. And the second resource is FrameNet, which is a network representing lexical and conceptual knowledge of frame semantics. Frames are basically conceptual structures describing particular types of objects, situations, or events, along with their components called frame elements. And in particular, we are focused on the core frame elements within the frame. So just to say that we are using both Princeton WordNet and the Bulgarian WordNet, BulNet, which you can find following these links. And also we basically use this visualization of BulNet compared to aligned with Princeton WordNet. And also we use FrameNet. So from the description of the frames in FrameNet, what we use is the definition of the frame, the core frame elements, as I mentioned. We also use frame-to-frame relations. And we also, as lexical information, we use the lexical units that are listed in each of the frames. How are we mapping WordNet to FrameNet? So what we start with is a list of various sets of mappings, which have been provided by various people, various teams working on that task. So here you can see some of those listed here. But the problem with these existing mappings is that they provide limited coverage. So only about 30% of synsets in WordNet are matched with a frame from FrameNet. So that's about 4,000 out of the 14,000 verb synsets. And also what we discovered in our observations was that not in all cases they are reliable. So what we needed to do is basically perform some consistency checks on the initial mappings that we got. Most of all, we focused on those that have different mappings coming from different resources assigned to the same synset. that were contradicting. And basically, some of these existing mappings, they've been compiled automatically. So it is expected that there are some things in them that need to be validated. And the reason for these preliminary consistency checks was that we start with good quality data, with reliable data, because of the procedures that we apply later on. And these are procedures that are aimed at expanding the coverage. And basically, if we start with something that has errors in it, these errors will propagate onto the data, and then our mappings won't be very reliable. And after we apply the procedures that I'll talk about in a bit, we finally implement further consistency checks and evaluation, and also followed by the need of manual validation if we want these to be reliable. So what we are trying to do, basically, we start with FrameNet and WordNet, and what we are trying to do is to find an alignment so that to every scene set in WordNet, we assign a frame from FrameNet. And not only that, but we would like this frame to be as precise as possible, so that it corresponds to the level of abstraction of the word in WordNet. So if we start with the scene set change, and we're trying to find a frame for it, we find that in one of the existing mappings there is a map from in which to the scene set change is assigned the frame calls change. So starting from there, what we examine is the relations of that frame on one side, calls change, and on the other side, we examine the relations within WordNet between the scene set change and other scene sets. And what we discover is there is a correspondence in inheritance relations. So we discover that the relation of inheritance in FrameNet is inherited by, and there is another inheritance relation in WordNet, which is the hypernym to hypernym relation. Then what we can do, we assume that basically the conceptual description of the verb is actually transferred from the hypernym to the hypernym. So in this case, we get the frame of change and transfer it onto the scene set stiffen. Stiffen makes stiffer or stiffer. And then after that, we are trying to check whether this is as precise as possible, or we could do better than that. So we examine the inheritance within FrameNet, and based on that, we can suggest the frame calls change of consistency, which is actually inherited from calls change. And then we examine other relations as well, right? Like the relation is causative or causes in WordNet, on the basis of which we can also do the same. So basically assign frames from FrameNet onto WordNet scene sets based on these relations. So as I explained, we explored the relational structure of both resources, particularly that of WordNet, and map frames to scene sets on the basis of the inheritance of conceptual features in hypernym trees. So by assigning frames from the hypernym onto the hypernyms. We rely on the assumption that hypernyms either inherit the frame of their frame or have a more specific frame, so have more specific semantics. So we need to narrow the frame, basically. So as I said, we use the inheritance relations in WordNet, but also in FrameNet, where the main inheritance relation is inherit from. So for example, the frame motion directional inherits from the frame motion. However, we extend the notion of inheritance within FrameNet also to include the so-called weak inheritance, with relations such as uses. For example, the frame body movement uses the frame motion. And also another relation, subframe of. So, for example, the frame halt is a subframe of motion. So we basically in FrameNet we consider strong and proper inheritance and weak inheritance as well. So what we do is we basically identify a synset that does not have a frame assigned yet, or its frame is assigned but is not validated. It inherits a frame from its hypernym. It can be done in 1, 2, or even more steps if the intermediate nodes in the WordNet tree have not been assigned a FrameNet either, a frame from FrameNet either. We then try to validate the frame or find a better fitting one, a more precise one. Procedures that are outlined below check consistency of frame assignments and make a list of suggestions. And if we cannot find a better fitting frame for the synset, then or there is some inconsistency in one of the resources or both, then sometimes we can propose additional additions to the resources or changes. Like, for example, what we discovered, for example, in WordNet, there are some synths that combine both the causative and the non-causative meaning, like, for example, the synth blacken, which can mean either make black or become black. But in this case, they basically need to be assigned different frames. So this is basically two different synsets that need to be placed in different places, in different trees within WordNet, and require two different frames. So one needs to be positive and the other not. So things like that, in cases like that, we can propose a change that applies to either of the resources. So our consistency procedures, what we decided to do is to outline the main procedures, but to illustrate them with some examples so that they become clearer what we are trying to achieve. On the other hand, if you want to get into the technical details of what we're doing, you can see the paper. The proceedings have already been published on the website. So basically the presentation will be mostly based on examples. So our consistency procedures, we use some procedures based on lexical and semantic analysis. Also procedures based on semantic similarity. Some ranking procedures when we get a list of suggestions, how we rank them so that we can basically see which one's fitting better. Also, our thoughts on proposing new frames, adding to the FrameNet resource so that it covers WordNet as much as possible, and also some words on manual validation that is required after that if we decide to get a reliable resource that is not entirely automatic, not entirely based on automatic procedures. So the first type of procedures is the lexical and semantic analysis. And the first procedure is to check whether, to use basically lexical information and to check whether any of the literals in the scene set appear as lexical units in FrameNet, in the frame of within FrameNet. So we first consider the frame that is assigned from the hypernym to confirm whether it's valid, and if any of the literals in the scene set appear as lexical units in this frame, it is very likely that it is valid. Like, for example, how we confirm that body movement is a very good candidate, is a very good match. The second one is also to check if the literals appear as lexical units, but we extend to cover more specific frames of the frame that is being assigned, so that we are trying to find a better fit. By more specific, what we mean is related through a inheritance relation, either direct inheritance, strong inheritance, or weak inheritance. So the third one, which is also to check whether the literals appear in as lexical units, but here we extend to sister frames of the assigned frame. So relation, and here, for example, if we see the verb educate, teach or refine to be discriminative in taste or judgment, it's been assigned from the hypernym, it's been assigned the frame calls to make progress. But what we discover a better fit. We discover the frame education teaching, which is a sister frame of calls to make progress. So in this case, it is not a more specific frame, but it is a frame that is in a different relation with the frame that's been assigned. And in that frame, education teaching, we can see the lexical units educate, school, train. Now what we're trying to do is consider the same operation, but now we don't consider relations between frames, we consider relations between scene sets. So what we get in this second type of test, second set of procedures, is we check whether any of the scene set literals appear as lexical units in the frames that's been assigned to its hypernyms, or is the frames that's been assigned to its sisters. So in this sort of procedure, we take, for example, the verb regenerate. It's been assigned the frame calls to make progress, but we see that in some of his hypernyms have been assigned the frame rejuvenation, and in it we can see the second literal appearing as a lexical unit, revitalize. So in this case, we give it as a suggestion that rejuvenation might be a better fit for this scene set. And as I mentioned, we also consider the current scene set. We consider its sisters as well, and we see all the frames that's been assigned to its sisters, so that we see whether any of those might fit better. For example, if we take the scene set nurse, try to cure by special care or treatment, and it's been assigned a frame from an existing mapping, which is medical professionals, which is one of those that are not very reliable in this case, because it's mixed up with the noun nurse. So in this case, what we see, we consider all the sisters of the verb nurse, and then we discover, and their frames, and we discover that in the frame cure, we've got the lexical unit nurse, and that's why we consider this to be a better match. So also we extend these tests we extend not only to cover frames that are being assigned to hyponyms or to sister synsets, but we also are looking for frames that are related to those frames. So related in the meaning that either are inherited or inherit from, or sister frames of any of those frames that are in the previous two procedures. So, for example, in remonstrate, what we are seeing here is being assigned the frame from the hypernym, it's being assigned the frame telling. And we look for all the frames for all the frames of the hyponyms, for all the frames of the sisters, and we take the relations of all the relations of these frames, and we discover the frame judgment communication. And in this case, telling and judgment communication are both related through an inheritance relation to statement. So they are both stepsisters. So that's how we get to this judgment communication, in which lexical units we find remonstrate, and that's how we suggest it. We give it as a suggestion for a better match. And the third type of lexical and semantic analysis procedure is to check whether any of the synset literals appear as lexical units in any other frame in WordNet. So we look for anything else in WordNet, frames that have not been related between each other. And as you can imagine, in this sort of procedure, we get a lot of suggestions, and not all of them are relevant, what we are looking for. For example, the synset abandon, give up with the intent of never claiming again, which is a root synset, so it doesn't have a hypernym, so we can't match it from there. In these cases in particular, this is a very useful procedure because it at least gives an idea where we can check for the frame of this verb. Even if it's not very precise suggestion, even if it's not the right one, it at least gives an idea where we might be looking for the frame. And in these cases, you can see some suggestions, and some of them are not very relevant. So another procedure is the use of keywords. We check for words that are contained in the frame name itself, or their derivatives, or we identify synsets with literals and definitions containing these keywords. So you can see some of the examples. Similarity-based procedures. What we test here is direct similarity between the verb clause and the definitions of lexical units in FrameNet. What we are looking for here is actually match between verbs and nouns and other verbs within the same within the definitions. In which case, for example, with Beto, we actually get the suggestion that cause harm has a good similarity level measurement with the gloss of Beto 3. So we confirm that this frame is maybe correct. But also we consider indirect similarity between glosses of synsets which are derivatively related to the verb and the clauses of their hypernyms and so on, in which case we can also get some informative suggestions. Then what we're trying to do is provide a ranking of all the suggestions. We order them by the score. There's some information about how we get the score in the paper. And sometimes even if we get like a higher rated suggestion, we basically here we can see that motion noise is suggested by 3 different procedures. So it's we need to figure out a combined score for each frame as well. And then, as I mentioned, we need decisions is made based on the manual inspection of the frame definition and frame elements. And we are still in the process of improving the automatic procedures so that they are more reliable and they give more reliable suggestions so that it minimizes the manual work. But we are not at this stage yet. We are still working continuously on it. So as our evaluation shows here, we are still, we still have relatively low precision of the procedures, of each procedure independently, but also we calculate relevance so that the suggestion is not only evaluated as right or wrong, but how informative, how much information it gives, where we can look for the correct frame. Not even if it's not precise, it can help us by saying, okay, it's somewhere here in FrameNet, so you get like a set of frames that you can check and find the answer there. So as I said, we need more work to minimize manual work, especially to outline new procedures, to analyze further the semantic relations, and to expand to other semantic relations as well. And it's been part of our work, is part of this project, was a semantic network enriched with a variety of semantic relations. Thank you.
Thanks to our speaker. It's time for questions now.
First of all, thank you for your talk. And the question is, do you use manual or automatic analysis in order to perform mappings from frames to specific text?
Features that I explained, they're all automatic. But at the end of the procedures, what we get is a list of suggested frames. So in some cases, if, there might be like a frame is suggested by many procedures, and then we confirm that it is the correct one. But in many cases, it is not as clear. So in many cases, different frames have been suggested, and we need to, what we are trying to figure out is to make like, to make a score that shows which is the most reliable one, so that we select it automatically. But it is very difficult. At the moment, what we do is we use the procedures, we get all these suggestions, and we manually choose which one is the valid one. So we combine automatic with manual work.
Thank you very much.
I can see that there is a question. Thank you. How do you decide how many levels of inheritance are sufficient? I assume the levels are different for different scene sets. Yes, so first of all, especially with regards to frames within FrameNet, in some cases, we discover that the inheritance there is not fully implemented. So, for example, what we saw is that, for example, all these, there are a lot of calls change subframe of frames that are that basically inherit from calls change but are not related to it directly. So we introduce this additional relations we add up to FrameNet, and all of these calls change of strength, calls change of consistency, calls change of this and that, we add them as inheriting from calls change, which helps us by adding these relations. It helps us to expand easier, we get a various different level of inheritance within FrameNet. And in WordNet, then it becomes a little bit easier because we can match this inheritance with WordNet. But especially when we, for example, if the root of the tree doesn't have any frame assigned, then we can't go deeper and deeper. Or if it's got, but then we inherit on the first step some if we've got a frame, then it's inherited by the hyponyms, then by their hyponyms, and so on and so on. And it becomes less and less reliable if it's inherited in many steps. So what we're trying to do is basically we're trying to confirm the key places where there are like a lot of tree going on down. We need to confirm manually this frame so that we at least know that the hyponyms of this synset are reliably matched with the frame and so on. So it's I don't know if that was precisely the question, but yeah, thank you.
Another question before we restart the system, because we can't avoid another way this noise. From YouTube channel, from Rusita, I don't know, for a minute I had to miss what you said, so if you answered, sorry. Have you tried to narrow the suggested frames by part of speech to avoid frames for nouns, suggested verbs, for example?
Yes, I mean, if we only consider frames that have already been assigned to verbs, so that we know, like in each frame, there's like lexical units listed, and we only take those that have at least one verb in them, so that we narrow down a little bit. But in some cases we might miss a frame, so it's never, it's never as clear with the narrowing. But yes, we were trying to do that as well.